this video, we're going to look at an example of a quadratic equation, and we are going to find a whole bunch of stuff out about the graph of this quadratic. This is a quadratic in two variables, x and y, and so we are expecting a parabola. So the first thing we want to do in order to graph this is find the most important point, which is the vertex. Now, we could do a whole table of values first, but sometimes you're sort of fishing for particular x values that are around the vertex. And so my advice is to find the vertex first and then use the vertex to build your table. So remember, in other words, to pick points, to pick x's to choose in your table, really. So let's find the x value of the vertex. Remember, that's the opposite of b over 2a. So in our parabola, our a value is positive 4, and our b value is negative 4. So we have the opposite of negative 4 over 2 times 4. So that's going to give us 4 over 8, which is a half. Interesting. We may not have picked half for our table. Let's go ahead and put that point in our table. It's an important point. So now the y value of the vertex, we're going to plug in a half for x and see what we get. So let's remember our order of operations here. We need to do the exponent first. And squaring a half is easy. You just square the 1 and square the 2. So 1 squared is 1, 2 squared is 4. So that's just a fourth. I'll go ahead and just rewrite this and then do the multiplication on my next step. Alright, so 4 times a fourth is just 1. 4 times a half is just 2. And then take away 3. So 1 take away 2 is negative 1. Take away 3 is negative 4. Alright, so now what I want to do is think about picking smart points for my x. So since my vertex is at a half, my axis of symmetry is going to be at x equals a half. So what I want to do is pick points on either side of a half, equidistant. So let's say I pick 1, alright? That's a nice number to pick. So if I pick 1 and I plug this into my equation, 4 times 1 squared minus 4 times 1 minus 3. I'm going to get 4 take away 3, which is negative 3. Now, do I want to pick x equals 0? I mean, I could, and that's kind of an easy one because it's easy to plug in 0. But notice that the distance between a half and 1 is a half a step. That's the same distance between a half and 0. So because of symmetry, I'm expecting 0 to come out to be negative 3 as well. So when you're graphing parabolas, you kind of get 2 points for the price of 1. Maybe we should start our graph over here so we can visualize what's happening there. So let's take a sec and go draw our graph and start plotting our points. So we have our vertex here at 1/2 negative 4. And then when we put 1 in for x, we got negative 3, which is right there. So this is what I'm talking about this symmetry. So I know my vertex is on x equals a half, so I have this line of symmetry right here. So if I find a point that's 1/2 of a unit to the right of the line, right here, 1/2 of a unit to the right, then if I go 1/2 unit to the left, I should also have a point at the same y value. Alright, so let's say we go to x equals 2 now. So whatever I get for x equals 2 should give me the same y value. Here's 2. That's not a point. That's a 2. It should give me the same y value for x equals negative 1, because that's the same distance from the line of symmetry. So this is what I'm talking about picking smart points. Let me erase that. Okay, so let's plug in 2. So 4 times 2 squared minus 4 times 2 minus 3. Let's see, 2 squared is 8 times 4. No, sorry, I got ahead of myself. 2 squared is 4 times 4 is 16 minus 4 times 2 is 8 minus 3. 16 take away 8 is 8. Take away 3 is 5. So this is a very steep parabola, which we would expect from this coefficient of 4. All right, when that a value is greater than 1, then our parabola becomes steeper than the standard y equals x squared, or thinner. Okay, so let's see. Let's plot this point. 2, 5. 1, 2, 3, 4, 5. So now I see this distance to the line is 1.5 units. So I'm going to go 1.5 units on the other side of the line. That's my symmetry. And I can also plot a point at a height of 5. And really, I mean, I've got a lot of room on our table, but this, I'm going to guess if I do x equals 3, it's going to go off the chart. It's going to get really steep. Maybe we pick 1.5. All right, so whatever I pick for 1.5, that's 1 unit. Excuse me, whatever y value I get for 1.5, that's 1 unit away from the axis of symmetry. So if I go 1 unit to the left, that would put me at -0.5. That's going to be the same y value. So this maybe is a calculator exercise. Why don't you pause the video and put 1.5 in for x into your calculator and see what you get. I got 0, which is interesting. That is an important point. That is our x-intercept. So that means my other x-intercept should be right there. All right, so now we have enough points to kind of sketch this parabola. Let's see how close I can get to these points. Ooh, that's pretty good so far. There we go. All right, so very steep parabola, which we would expect with that a value. And you can add some more points, but because of this whole 2 points for the price of 1 thing, you may not need to fill out the whole table to get a really nice graph of the parabola. All right, so we already did part C. We graphed the parabola. Now the last thing is to find the intercepts. Well, having the graph, we could see what the intercepts are, right? The x-intercepts on our table, we could see right there. Let's jot these down. We're also going to find them algebraically for practice. You don't always draw a graph when you're trying to find the intercepts, but I can see that my x-intercepts are 1.50 and -0.50. My y-intercept is right there. What is that, -3? 0, -3. 0, -3. Okay, so how would we do this algebraically? Well, the y-intercept algebraically is easy because you just plug in 0 for x. So we have y equals 4 times 0 squared minus 4 times 0 minus 3. So that's -3. So y-intercept, we let x equal 0. And now for our x-intercept, when we do that algebraically, we're going to let y equal 0. And this is a little more work to solve, right? So we have 0 equals 4x squared minus 4x minus 3. So methods for solving quadratics, can you think of them? We could factor, we could use the quadratic formula. Actually, this guy will factor, and the quadratic formula works on everything. So let's try to factor it first, and then we'll go do the quadratic formula. All right, so I know that what goes here and here has to multiply to be -3. And what goes here and here has to multiply to be 4. Now, or 4x squared. I know there's only one option for that 3, so that's 3 and 1. So I'm going to go ahead and put those in. Oops, that was in the wrong spot. It should be in the yellow spot. And we need one positive, one negative. I'm not sure which one's going to be positive and negative. I'll just guess that. And now for 4x squared, I need to pick either 2x, 2x, or 1 and 4. And then we'll check and see if we have that middle term. I don't know. Let's pick 2x and 2x just to start and see. All right, let's check that middle term. So this would be, oh, I just got lucky. That would be -6x, and that would be a +2, and those add together to give me -4. If it would have been +4, I could have switched the positive and negative, but I got lucky here. All right, so awesome. Sometimes that's great. So now we set each of these equal to 0. and solve. So we'll subtract the 1 over and divide by 2. And then we will add the 3 over and divide by 2. And we get what we got in our table. We have them as decimals, -0.5 and +1.5. All right, awesome. So just for practice, let's go over here and solve this using the quadratic formula. I think that's good practice. So our quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And my a value is +4. My b value is -4. That's going to go there. And my c value is -3. All right, so if you feel pretty confident, maybe you pause the video and go ahead and do that. And then unpause it when you're done. If you'd like to follow along, then let's keep going. All right, so x equals the opposite of b. So that's going to be +4 plus or minus -4 squared minus 4 times a, which is 4, times c, which is -3, all over 2 times a, which is 4. So we're going to use our order of operations underneath that square root there. -4 squared is 16. 4 times 4 is 16, times 3 is, 48? Now I got to be careful here because I have a negative and another, or I have a minus and then another negative here. So this product is going to end up being negative. This product of these three things is -48. So I'm minusing -48, which is going to be a +48 over 8. All right, let's keep going here. So we have 4 plus or minus the square root of 64 over 8. Now 64 is a perfect square, and I would expect that because this factored. Because this factored, I'm going to expect that what's under the square root is a perfect square. So now I'm going to split this up to 4 plus 8 over 8 and 4 minus 8 over 8. So that gives me 12 over 8, which is 1.5. And this one comes out to be -4 over 8, which is -1/2 or -0.5. All right, lots of good stuff there. I hope that helps with graphing parabolas.